Logarithmic and Exponential Equations, Chapter 5, Section 6. So let's look at solving logarithmic equations. Remember, y equal to log base a of x is equivalent to x equal to a to the y, where a is greater than 0 and a is not equal to 1. Right? So remember that there's that relationship between them. So you can change a log equation into an exponential equation. You can change an exponential equation into a logarithmic equation. And if log base a of m is equal to log base a of n, then m is equal to n. Just like with the exponential, if you have a to the m is equal to a to the n, then m is equal to n, where m, n, and a are positive and a is not equal to 1. Also, as I said, if a to u is equal to a to the v, then u is equal to v, where a is greater than 0 and a not equal to 1. So we're going to bring these three things together to solve logarithmic equations. So I want to solve the following for x. Log base 3 of x minus 2 is equal to 4. Now I've got the x inside my logarithmic equation, or my logarithmic expression. So what can I do? Well, I can use that rule that log base a of x is equal to y, therefore a to the y is equal to x, right? So I can swap this to an exponential equation and say that's 3 to the 4 is equal to x minus 2. Well, I can find 3 to the 4. 3 to the 4 is 81. So 81 is equal to x minus 2. So if I add 2 to both sides, I get x is equal to 83. So that took something that looked difficult into something relatively straightforward. Let's try another one. Let's solve for x. Log base 263 of 3x squared plus 5x minus 2 is equal to log base 263 of 3x squared minus 5x minus 8. Now that looks horrible. I don't want to deal with a log of 200 and log with a base of 263. But wait, both sides of the equation are logs with base 263. Log base a of m equal to log base a of n, m is equal to n. I can get rid of those logs. So I'm left with 3x squared plus 5x minus 2 is equal to 3x squared minus 5x minus 8. Well, handily enough, if I subtract 3x from both sides, they disappear and I get 5x minus 2 is equal to negative 5x minus 8. So if I get the x's on the same side and the constants on the same side, I'm going to add 5x to both sides and add 2 to both sides, which gives me 10x is equal to negative 6. Let's get the x by itself, so divide both sides by 10. And I get x is equal to negative 6/10, which reduces to negative 3/5. So just taking advantage of the fact that if you have a log of some base of something equal to the log of that same base of something, that the somethings are equal and you can get rid of the log itself, which in this case turned it into a really easy thing for us to solve. So that's the process, just using these different properties and recognizing that we can change logarithmic equations into exponential equations and exponential equations into logarithmic equations. And if you're dealing with two logs of the same base set equal to each other, whatever's inside those logs must be equal. If you're dealing with two exponentials with the same base that are set equal to each other, then the exponents must be equal to each other, which allows us to go through and solve these. So not nearly as painful as you thought it was going to be, and relatively straightforward.